Hello, welcome back. If I dare to, I believe I'm going to attempt another example. So, picking up where we had left off, this is example 6-4. I cannot recall the exact page number, but it's in section 6-1 from our textbook. And my document camera hates me. All right, let's try it again. Okay, so in each one of these, we're going to find the probability for each. Assume that this is a standard normal distribution. Okay, so we're going to go through each one of these one by one, and I've got a dazzling workaround for the focus issues when looking at the table of values. I'll just put it on top of the book. There we go. All right, so here we are. We're going to find the probability P 0 is less than Z is less than 2.53. So what does that mean? Well, here. The first thing that we're going to do anyway is sketch our normal distribution, which is just a rough sketch of the bell curve. And then on here, we're going to mark the pertinent Z values that it tells us. So here is 0. Where should that be? That should be right smack in the middle of the bell curve. And over here, 2.53, it's not accurate, it's just a sketch, but 2.53 is larger than 0, so it should be to the right of 0. And now we are finding this area. So the probability that 0 is smaller than Z and at the same time Z is smaller than 2.53, or in other words, Z is between 0 and 2.53, that is essentially just using our Z distribution, our standard normal distribution, to find the area in between these two Z values. Okay, so let's recall how we would do that. All right, bring in the table. There it is. All right, so first of all, we're going to go ahead and look up the left area for 2.53. So finding 2.5 on our row. There it is. And then 0.03 for the column. So we're going to trace over to the 0.03 column. All right. Make sure I'm reading in the right column. Let's see. Yeah. Okay. I'm in that 0.03 column, staying in that column. My finger's on that value and 2.5. So we're looking up this value here. We see it is 0.9943. Just going to write this down over here, 0.9943. All right. So, and then we're going to go ahead and look up the left area to the left of 0. Okay. And then remember that we're going to subtract that away from the left area from 2.53. Okay. And, this is one where we don't even have to look it up because of the symmetry of the bell curve. 0 and to the left, that is exactly 1/2 the left half of the bell curve. So already, I know I can just pencil in 0.5000. 0.5, nothing but zeros after that. If you don't believe me, convince yourself. Okay, here is 0.000. Okay, so there it is, and that is exactly 0.5, like it says. We didn't even have to look that up. All right, so let's put that aside for the moment. And here we could use a calculator. I could probably do the subtraction. I don't know, maybe. We'll see. Let's see. 439, and got it. All right, so we have an area of 0.4943, so that is what that probability is equal to. We can write the final answer as this probability is 0.4943. Or, in other words, we have a 49.43% chance of our Z value falling within these values. Or To put it another way, 49.43% of all of the values in our z distribution are going to be in between 0 and 2.53. All right, so let's move on. The next one is a left area. How can I tell? I can never remember. So I'm going to sketch the distribution. I was looking at it ahead of time. I was thinking about how would this sketch look. So there's 0 in the middle. Here's 1.73. Again, doesn't really have to be super accurate. We just want to get a mental image of what this is going to look like. So z is less than 1.73 on our x-axis. Those are the z values. We should have basically everything shaded below or to the left of 1.73. So this is one where it is a left area. All we have to do is plug in 1.73 into our z table and just read off that value. That would be it. Sorry, I have to go back up to the previous one and just include what is that number? Okay, all right. All right, so let's do that. Here we're on the same side as we were. We're on the positive z values. We're going to slide on down to 1.7 and then go over to 0.03. So there I'm seeing 0.9582. 0.9582. What does that represent? That represents the probability or the area underneath that probability distribution curve. So the probability is 0.9582. We could write that as a percentage as well. I just don't want to do it. In part C, notice that this one is a right area, but I was just thinking about it ahead of time. I wouldn't know it just to look at it, all right? So what does this one say? Here is 0 right smack in the middle. We'll identify that critical value, 1.98. That's approximately where it is. Anywhere to the right of 0 is fine. And now look, we want our z values to be greater than 1.98. If we were looking at this as an inequality, our z values would be over here to the right of 1.98. And so we want the area underneath the distribution curve located to the right beyond z equals 1.98. All right, so here I'm going to employ the shortcut to find the right area. I'm actually just going to plug in the opposite. Instead of positive 1.98, I'm going to flip to the negative side. Here, got to locate negative 1.9. We're going to go all the way over to the second to last column, which would be this one here. That is the 0.08 column. So 1.98 gives us 239. 0.0239. So that is that area there. Okay, and so refer back to the previous video for an explanation of why I did that sneaky business right there to find a right area. You're going to want to know the sneaky trick for right areas. And we'll stop there. Thank you.